Hi guys, today we are going to discuss about the proof of cos of x plus y equal to cos x cos y minus sin x sin y. So here, let's take a unit circle. Since it is unit circle, so the coordinates of this point A is 1, 0. Draw another line OB. So let's consider this as B, which makes angle X. Now draw the other line. Let's take it as C, and it makes angle Y. We also draw another line from O, D. Let us take this as D, which makes angle minus Y. Let's join BD and CA. So let's join CA. Now let's try the coordinates of B. Coordinates of B are cos x, sin x. So you may get the doubt how it is. Again, let's take a unit circle. There is a point Px, y. Join OP as R. Draw the perpendicular from point to x-axis. So the distance from the point to x-axis is known as y-coordinate. The distance from point to y-axis is known as x-coordinate. Now suppose if it makes angle theta, now sin theta equal to, so opposite y by r. So we can write this as r sin theta equal to y. Since it is radius is 1 unit circle, so the value of y is sin theta. Similarly, we can find cos theta also. Cos theta is adjacent by hypotenuse x by r. So r cos theta equal to x. As we know that r is 1, we can write x is cos theta. So here we replace this as sine of this angle theta. So this is cos of this angle theta. Using the same concept, this is cos of angle x and this is sine of angle x. Similarly, we can write now the coordinates of C are, we are considering this angle. So this is x plus y. So it is, the first one is cos x plus y. And the next coordinate is sin x plus y. Similarly, the coordinates of D is dr. We are taking in this order. So it is cos of minus y and sin of minus y. So let's simplify here itself. This is cos of minus theta cos theta. So cos y. Sin of minus theta is minus sin y. Hopefully it's clear. Let's consider these two triangles OB D and OCA. In these two triangles, these are equal since they are radii of the circle. So let's take these two triangles. The first one is in this shape. So B, O, D. And the other one is in this shape. A, O, C. So if you observe this, from here to here, this is y units. And from here to here, it is minus y units. The sense minus, here negative sign shows the direction, but the magnitude remains y and y units only. Now, if we add this, suppose A, this is also, this will be A only. So the sum of these angle is y plus A. This angle also y plus A units. That means these two angles are equal. Already we know that these sides are equal. These sides are equal since they are radii of the circle. Now using SAS congruency criteria, triangle OBD is congruent to triangle OAC. Hence, the corresponding parts are equal. So we can write BD equal to AC. Now, we are going to start the proof. So first of all, we have taken. So let us consider a unit circle and angle AOB equal to X, angle BOC equal to Y, also angle AOD equal to minus Y. Now, we just discussed it so that we know that triangle OBD is congruent to triangle OAC. This is by SAS congruency criterion. so that their corresponding parts are equal, we can write this as BD square equal to, BD equal to AC. Now, squaring on both sides to get BD square equal to AC square. Let us consider this as equation 1. As we know that BD means the distance from between B and D. AC is the distance between A and C. When two points coordinates are given, the distance between them formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So let's use this formula. Let us find BD square value. So BD square equal to x2 minus x1 whole square, right? So let us consider this is x1, y1, and this is x2, y2. Or either you can take x2 minus x1 or x1 minus x2, any one of them. So x2 minus x1 is cos y minus cos x whole square plus minus sin y minus sin x whole square. Now we can write this as, it is in the form of a minus b whole square. So the result is cos square y plus cos square x minus 2 cos x cos y plus, here let us take minus common. So it becomes minus of sin y plus sin x. So minus square is positive. So we can write this as, we do it here. Minus take common. So we'll get sin x plus, this is sin y plus sin x whole square, which is nothing but minus whole square is plus. So it is sin y plus sin x whole square. Or directly also we can do it, minus sin y whole square like that. So let's use this. So we can write this value is sin square y plus sin square x plus 2 sin x cos x. Now cos square y plus sin square y is 1. So this is 1 plus, here it is, cos square x plus sin square x is also 1. Now from these two terms, let's take minus common. Then we get minus 2 times cos x cos y. Minus already took common, so this becomes minus sin x sin y. So if we simplify this, this is 2 minus 2 times cos x cos y minus sin x sin y. This is the value of BD square. Now let's find AC square. Now AC square equal to, let's consider this is x1 y1 and this is x2 y2. Then we can write x2 minus x1 whole square. So this is cos of x plus y minus 1 whole square plus sin of x plus y minus 0 whole square. So this result is, it is again in the form of a minus b whole square. So a square in the sense cos square x plus y plus 1 square is 1 minus 2 times cos x plus y plus this result is sin square x plus y. Again, cos square, it's in the form of cos square theta plus sin square theta, which is 1. And let us add this plus 1 minus 2 cos of x plus y, that equal to 2 minus 2 cos of x plus y. This is s square value. Now, this bd square and s square values, let us substitute in equation 1. Therefore, 1 implies, as we know that it is bd square equal to ac square. We got bd square as 2 minus 2 times of cos x cos y minus sin x sin y equal to ac square is 2 minus 2 times cos of x plus y. Now, these two gets cancelled. So we can write this as minus 2 times of cos x cos y minus sin x sin y, which is minus 2 times of cos of x plus y. Then divide by minus 2 on both sides. Therefore, we get the result as cos of x plus y is cos x cos y minus sin x sin y. That's all. Hence proved. If you like my video, please like it and share it. If you have any queries, so please post the queries in the form of message so that I try to solve it. Thank you guys. See you in the next class. Oh, చిన్నదేనా? చూడు.